Welcome to the Stormsurf video surf forecast for the week starting Sunday, September 23rd. Looking at significant wave heights for the South Pacific Ocean, we see a rather calm pattern, but the good news is that's not supposed to last very long. We'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for a trough, that is, the jet, specifically the southern branch, right there, that's the northern branch. That's not the influential one, it's the southern branch. We're looking for it to push to the north, and that would help form a clockwise flow, and that is, of course, the sign of low pressure in the southern hemisphere. And that clockwise flow aloft and down at the surface, helps create winds, and winds, of course, generate seas, and seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, creates surf. All right, so we see something that almost, maybe, kind of looks like a trough here south of New Zealand. There's Antarctica. Now the ice line's right around 65, around there, so it's just barely clear of the ice line. But then as you get into the central South Pacific, we see a ridge that is the opposite of trough. The winds push to the south over Antarctic ice. That helps create high pressure in between the split in the two jet streams here, so like right there. That's not good for the production of swell. So right now, this little area is our only hope as of 18Z Sunday. We look, and look at this. As we get into Monday, a semi-decent, for the first time in a long time, semi-trough-like feature is supposed to develop south of New Zealand, being fed by winds to 120 knots. That right in there would help support formation of a little bit of a gale. Now, the winds start dying off as we get into Monday night and Tuesday, but still the trough persists. And then as we get later into Tuesday, the trough continues to hold, though very weak. I mean, we're looking at, 70, 60 knot winds. That's not very much, but we'll take anything. Notice on the east side of the trough, a big ridge pushes hard into New Zealand. Into Antarctica. That would completely shut down swell production. And then we see the trough just getting weaker and becoming disorganized as we get into Thursday. And that pretty much is the end of that. A zonal flow, that is the jet running from west to east, sets up over the ice line right around 65 there. That pretty much shuts things down. We'll sort of look and see here. Almost looks like maybe another trough might maybe try to want to organize southwest of New Zealand a week out on Monday. Wouldn't believe the models. For the most part, this looks like just massive high pressure in control. Now this is just looking at the upper atmosphere. The upper atmosphere kind of gives you a sense. It's the energy source for what goes on down at the surface. So given that, let's go take a look down at the surface and see what's going on there. So here we are, surface level pressure, surface level winds. We see, when we're looking, we really need to see 40 to 45 knot winds to build swell with enough of a period to reach the whole way up into California and Hawaii. Yeah, Tahiti, we're right around in here, generally can handle, get the swell, whatever swell is generated. If it's, seas are only 20, 22 feet, something like a 13, 14 second period, that swell will make it to Tahiti, but not the whole way up to Hawaii, not the whole way to California. That's a 5,000-6,000 mile journey. So you need higher seas, which typically means more wind, and more wind energy running over the ocean surface creates longer period swell, and longer period swell, of course, takes longer to decay, and therefore can travel farther and maintain some semblance of size. So we see some low pressure here developing late Sunday night south in New Zealand. There we go, little tiny patch of 40 knot winds. Monday morning, building to a little tiny patch, a broader patch of 40, let's say 35, 40, little tiny patch of 45 knot winds. And the key here, aimed to the northeast, not aimed off to the east. And continues now. The downside is it looks like it's all targeting New Zealand initially, but then it starts to ease east of, out of the shadow from New Zealand relative to Hawaii and the U.S. West Coast. As we get into Tuesday, nice little patches of 40, 45 knot winds. We're not looking for anything huge here. Even better as we get 18Z Tuesday. And there we go, 45 knot winds almost aimed due north as we get into Tuesday night. 50 to 55 knot winds on late Tuesday night. This is actually looking pretty good. Some decent setup for nothing huge, but a decent size, long-lasting fetch aimed well to the north. and actually kind of lifting to the north a little bit. There is some hope for some swell production. And even past that, as we get into Wednesday night, still 30, 35 knot winds relative to Tahiti. Plenty of swell should result there. And then the whole thing falls apart. We know what happens after that. Big ridge sets up and everything gets squashed. Sure enough, you can see it. Winds, all the winds, this little fetch here, all pointing southeast. And that's the end of that. Another system tries to squeeze under New Zealand. Remember, ice line is right around here. Only 35 knot winds. This is on Sunday. Not enough to generate swell, except for maybe Tahiti. And that's the end of that. All right, at least it's looking favorable. Let's go take a look at the wave models. And we're actually going back in time. This is last Sunday, the 16th of September. We want to show you a little gale developed under New Zealand, 32-foot seas. And it built, what's that, 42-foot seas supposedly? But the track was to the southeast. So we'll just watch this, and then it died. Okay, we'll go back through this. So it started out, right there. So what's that, at about 55 south, and it peaked out down at 57 south, and then continued east on a track around 58 south. So basically, and then faded. So basically, a pure east moving storm, no real fetch pushing to the north, no storm motion to the north. So whatever swell is no swell is expected for Hawaii. The tiniest bits of swell, mainly for exposed breaks in Southern California. Maybe some dribbles into Northern California. Oh, I'm thinking early to mid this coming week. So nothing a whole lot, and then nothing after that. So then we get to the more interesting scenario. Here we are today, 18Z Sunday. Let's see. We saw there's fetch supposed to be building here. There's a trough here. Let's see what happens. What is the effect of those winds on the ocean surface? And we see, there you go, as we get to 18Z Monday, little area of, we'll say 31-foot seas, pretty much shadowed, certainly shadowed for Hawaii, certainly shadowed for, maybe not completely shadowed for California, and not for Tahiti. Now, continuing in the shadow, but then we get into Tuesday morning. What do we have? 34-foot seas, and holding in that range, a little area of 30, what's that? 30, 32, 34, 36, 38. It says 39. Not a chance, and it's such a tiny area. And there we go. 42-foot seas, supposedly. So this is the best model run yet so far. Probably overhyped, 66 hours out. Probably won't be that big, but we'll see. And that continues into Wednesday, lifting, and notice that, moving reasonably a bit to the northeast. That should make for some decent swell for California, Hawaii, Tahiti for sure. And then the system fades out as we get into Thursday. So, actually, maybe a hint of southern hemi swell could result if all this plays out. Remember, this is a forecast, a projection. The models don't know exactly what's going to happen. It will unfold the way it is. The only thing that really matters is the 0-0 hour forecast. And we'll run this out. Okay, and we continue to look here for the next week. Another little dribble under New Zealand, barely 30-foot seas. Probably no swell from that. Okay, the 0-0 hour hindcast. This is reality. This is what is happening right now. That's the only thing that matters. 6 hours from now, there'll be another model update. It will not be this frame. It will be yet another projection of what's currently happening right now. So the previous thing we showed you right here, this wave model here, so it says hindcast, 0Z hindcast. The next one says 0Z hindcast. So this is going back, the retrospective of what has happened over the past week. We take all the 0Z hindcasts from every run of the model, concatenate them, so you can see actually what really happened as best can be determined by the model. Okay, so there's still a little bit of inaccuracy in here, but it's not some fakey forecast projection. Though the models do a pretty good job 3 to 4 days out, but this is what actually happened, and this is what you would use to actually try to make a surf forecast with a reasonable degree of accuracy. And so let's take a look at the North Pacific while we're at it too. So right now, not a whole lot going on, but we're in that time of year when one would certainly expect to see some sort of development in the North Pacific. We've had nothing so far. very late starting season. But tropical system, typhoon Trammy, winds 120 knots, that's 138 miles per hour, and forecast to build. And rather than show you the wave model, let's go look at the official projection. Here it is. Here's Taiwan. Here's South Japan. We're down here somewhere. Winds 120 knots. Forecast to build to 145 knots, which is 167 mile an hour sustained winds on the 24th 18Z. So where's that? That's somewhere down here. Basically a fish storm out in open ocean, and then projected moving towards, let's say, northern Taiwan, but weakening significantly down to 115 knot winds. Still pretty solid, but certainly a swell generator for the any locations right in this area. If you happen to be surfing in this area, good odds for large, long period swell. So we continue on. We're sort of keeping an eyeball here, but we're kind of looking at some other things too. Now, notice this model has it pretty much stalling right here. This is the GFS models driving this. Other models are driving the official track. Notice a gale forecast to develop north of Hawaii on Wednesday night. Building, supposedly, it's been all over the place. No, per this model run, nothing. Also notice some sort of tropical activity south of Baja, too. Also notice Trammy here, still not moving decidedly towards Taiwan, and then something developing off of North Japan as well, building with a tiny area of 30-foot seas late in the work week. We're talking Friday night. We're almost a week out. And building to, what's that, 30, 32, 34, maybe 36 or 37-foot seas. But Trammy almost moving into Taiwan. What's it do? And I'm watching this on the dateline. Oh, and another gale also in the northern Gulf with 22-foot seas. Trammy, does it recurve to the northeast? It does. Yes, it does. And we're at 180 hours out. Don't believe any of this. Be interesting to see. So let's go back. We're going to sort of dissect this. Okay, we're starting on Saturday. Little system in the Gulf, 22-foot seas, maybe good for tiny 13-second period swell in the U.S. West Coast, a couple days beyond. Another system moving aft over the dateline, 32-foot seas, maybe some 16, 17-second period small swell for Hawaii, and certainly maybe even smaller for the U.S. West Coast. I mean, just eyeballing it, 1.5 feet, 2 feet at 17 seconds, something like that. And then maybe Trammy recurves, hits the jet stream and builds. And notice a lot of tropical activity forecast here. Don't believe any of this. The reality is the active phase of the MJO is supposed to be over in the Atlantic at this time, which would mean that's where all the tropical activity would be. That does not preclude it from happening here, but this seems a bit overhyped. And then a quick look at wind swell. Okay, currently high pressure. Here we go, 1030 millibars in the Gulf of Alaska, creating a bit of a pressure gradient along the North California coast, generating 25-knot winds. There was actually a little bit of small swell at select breaks in Northern California today. You know, chest high, something like that. Maybe some shoulder high peaks at a couple of spots. The best tide with the most exposure. Hawaii, no wind swell. You need a good area of 15-knot continuous fetch. We're not seeing it there. So we'll just roll this out. So wind swell probably building into Monday. Notice winds building to 30 knots over Northern California. Light wind pattern near shore. Probably wind swell come Monday. Nothing for Hawaii. And then winds, up to almost 35 knots Monday afternoon with a light, probably a southerly flow, eddy flow into California. And then that starts to fade out relative to California. Here's that low developing in the Gulf as we get into Tuesday night and Wednesday. This thing has been on and off the charts. It looks pretty good here, but notice most of the fetch, there's high pressure here, low pressure here. That's where the gradient is. Off the backside, barely 30-knot fetch. Most energy moving towards Alaska. Probably some sort of small continuous dribbling wind swell, mainly for Northern California down into maybe Monterey Bay, something like that with 20-knot winds there off of Oregon and Washington. And even that starts fading out. Watch for, here's the low in the Gulf north of Hawaii. There's your little tiny, just a well, actually, it kind of looks better here than what it looked like. Oh, this is the 12Z run of the model. We were looking at the 18Z run of the wave model. My guess is that the 18Z run, when it posts, winds will not be as strong as what we're seeing there. That's what the wave model was picking up on already. So probably that's a bit overhyped. And then notice this generic low pressure sets up over the U.S. West Coast. Light winds near shore, no wind swell, and oh, look at that. Interesting low pressure, not strong, 25 knot winds. A little bit too far off the coast. Where are we here? 600 miles off is somewhere out around here, and that's more like 900 or more miles off the coast. Something to watch for, maybe even some precipitation. We'll see what happens, but that is definitely a sign of a transition to a fall pattern. No high pressure, low pressure setting up. Bring it on. We need it. All right, there's been a lot of discussion around what's possibly El Nino developing. Well, maybe. We'll see. Let's look at the data. But let's just look long-term. What's going on with the MJO first? That sort of gives us some clues. Short-term, long-term outlook. And then El Nino is the real long-term outlook. First off, we like to examine equatorial winds on the equator. East Pacific here, West Pacific here. There's the equator right there. That's New Guinea there. Dateline right down the middle. This data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, or the development of El Nino. We can also use it to sort of get a sense of what's going on with the MJO, Madden-Julian oscillation, and to see if perhaps Kelvin waves are forming. Kelvin wave, of course, warm water that seeps from the maritime continent into the West Pacific when winds and trades die in this area. And then if you get some west winds, actually develop a ball of warm water that travels under the ocean surface, travels completely across the Pacific under the equator, and then erupts near the Galapagos, and that can help usher in El Nino. So we're very interested in that sort of situation. Right now, winds from the east, look at the arrows, lots of east winds to the dateline, then winds die in the West Pacific. What we're really interested in is anomalies, differences from normal for this time of year. And you see these little arrows here, kind of a mixed light pattern, meaning, yeah, these trades strong from the east, but you know what? That's normal for this time of year. Now, the interesting thing, notice how the winds die here. Well, look at this. West arrows, west arrows, west arrows. That means that basically it's the equivalent of west winds in this area. That is a sign of the active phase of the MJO, or perhaps El Nino, and that is what is conducive to Kelvin wave formation. And of course, Kelvin wave formation is conducive to the formation of El Nino. Let's do a quick inspection of what's been going on the past few days. Okay, so here's the equator right here, South America, Galapagos, like right there, New Guinea right there, Australia, Kelvin wave generation area, 135 west, so right here, far west Pacific, 5 degrees north and south of the equator, over to about 170 west, so right in there. Okay, the oranges are west anomalies. So this is up 850 millibars. That's about 4,700 feet up in the atmosphere. We're going to put a good proxy for what's going on down at the surface. That was as of September 17th, and we just go day by day. And you see, yeah, there's been this persistent west wind, and building west wind pattern through the 21st. So this westerly thing has been going on for a couple of days at least. Let's look at the forecast. Okay, so here's the same thing, but this is the whole planet on one chart with time as a function. So the date line is right down the middle of the chart, 180 west. Kelvin wave generation area, 135 east to 175 west. So right between these two tick marks, and you just start going down, and you're looking for oranges and yellows. There we go, right there. September 5th or so, westerly anomalies started developing in the Kelvin wave generation area and have persisted, if not gotten stronger, though there were some easterly anomalies in pockets. Here's where we are today. Good solid patch of westerly winds, not a westerly wind burst. That's where you get really strong winds, but maybe bordering almost on that right now. And here's the next week forecast, 7 days. Forecast to continue through September 28th or 29th. And there's this little ball of easterly anomalies forecast. A little bit suspicious. Let's see. Let's go a little further out. Let's see if we can get a 2-week look at. So this is outgoing long wave radiation, a little bit different. We're not looking at winds anymore. This is looking at ocean or sunlight reflectivity off the ocean surface. If you see yellows and oranges, look at the scale. It means more sunlight reflectivity, positive numbers. That means high pressure. That means the inactive phase of the MJO. And this is the statistic model, so this doesn't look good. This says the inactive phase of the MJO is supposed to be building over the next 2 weeks. The dynamic model, which is a version of the GFS model, basically says the same thing. Not as strong, but still inactive phase of the MJO. All right, phase diagram chart. So what's this thing? Assume you're looking, this circle, assume that's like the North Pole. You're looking down on the North Pole, and the active phase and the inactive phase move from west to east, from the Indian Ocean, over the Maritime Continent, over the West Pacific, under the United States, across the Atlantic, across North Africa, back to the Indian Ocean. The heavy dot is where the active phase of the MJO is, so it's in the Atlantic. And the further away the dot is from this circle, the stronger it is. So this says the active phase of the MJO is, over the central Atlantic, I guess we'd say, and forecast to get moderately strong, and then supposed to push its way into Africa 2 weeks out. Okay, and where are we? We're over here somewhere. So this means probably the inactive phase of the MJO is on the exact opposite side of the chart, Maritime Continent, moving towards the West Pacific. So basically, like what we saw in the other charts. The GEFS model, saying basically the same thing. Now, wherever the active phase of the MJO is in summer months is where you're going to see tropical activity, because the active phase of the MJO is just like a low pressure. And if you got low pressure sitting over the tropical Atlantic in the summer months when the water temperatures are the warmest, then odds are if other things come together, you're going to get tropical activity. One would say better keep an eye out for the Atlantic. So when we see all those tropical storms that were supposed to blow up a week out on the GEFS model, or the GFS model, it seems a little bit suspicious. That looks like what would happen if the active phase was in control, but if the inactive phase is in control, not sure I'm buying it. Okay, upper level model, jet stream level model. Where the green is where the area favorable for precipitation is. So one could say, well, maybe the active phase of the MJO, that we see green, there's Africa, there's South America. So this is saying over the East Pacific. And then we see, what's this? The exact opposite, not favorable for precipitation over, well, there's New Guinea there. So this is the Maritime Continent. And you see the inactive phase building, filling the Pacific as we get into late September. I'm just looking at the dates over here, pretty much the whole way through to the 23rd of October, and this is probably about a week earlier than what happens down at the surface. So most of October is supposed to be locked out by the inactive phase of the MJO, and that pretty much stomps on storm and swell production. And then as we get into late October into November, that's when the active phase of the MJO, theoretically, per this model, is supposed to start building in the Pacific. And yet, one more view. CFS model. Okay, same deal. This is the whole world on one planet. This is winds, westerly wind anomalies, the oranges and the reds. Date lines right here, Kelvin wave generation area between these two tick marks like there, so you just work your way down. Notice, see all the tropical systems. When you have westerly winds, which is associated with the active phase of the MJO, and if those westerly winds persist, it's the formation of El Nino, and you can see there's a pretty good correlation, but not completely. Anyway, so here's where we are right now. Strong westerly winds. This says, it says MJO, black. That looks like the active phase of the MJO in the Pacific and these are in 1 week intervals for maybe another week, and then it moves out. The dotted line means inactive phase of the MJO, pretty much for the whole month of October. Easterly anomalies developing in the far west Pacific. So here's sort of the bummer on all this is this model previously had been saying westerly anomalies the whole way through the month, but now it keeps getting stronger and stronger, suggesting easterly anomalies building. That is not a sign of El Nino. That is sort of the opposite of, I mean, it's not La Nina, but it's not really conducive to the development of El Nino. All right, one more model, even longer term. All right, CFS model again, same deal. Whole world, a whole planet on one chart. There's the dateline Kelvin wave generation area between these two tick marks. The only difference is time goes in this direction on this chart. Instead of top to bottom, it's bottom to top. So here's where we are right now. And yellows are westerly anomalies. Westerly wind burst, it looks like developing for the next, we'll say a week. And let's overlay the MJO. See, it's not really, it's sort of saying, yeah, some hint of the active phase of the MJO, not as strong as the other one, but clearly moving into these dotted contours, the inactive phase of the MJO, taking over from October 1st to the end of October. So pretty much the whole month of October shut down. Easterly anomalies, so the western edge of the Kelvin wave generation area at 135, so what this is saying that easterly anomalies really aren't supposed to make it into the West Pacific. They're supposed to be held isolated over the maritime continent. That would be good with weak westerly anomalies in the Kelvin wave generation area or neutral anomalies. So that's a more favorable outlook. Now, the good news is, of course, active phase of the MJO developing late October, holding through at least mid-November. This model has continually bounced day by day, showing strong westerly anomalies, westerly wind bursts, and then the next day it turns around and say, well, maybe not quite that strong. So it's having a hard time making its mind up. But we are talking a month more out into the future. So not surprising that there is some ambiguity as to the exact outcome. Regardless, westerly anomalies continuing through at least December. Now we overlay the low-pass filter. Here we go. And this is, we'll say, these contours are a low-pressure bias, building solid, well, basically holding solid the whole way through till December. We were looking at this chart yesterday. It actually went to 4 contours, and it's doing the same thing day by day. Well, 3 contours, then 4 contours. So it's having a hard time, but it continually is showing the dotted contours here. High-pressure bias at 160 east to 90 east. That's in the Indian Ocean. So this is a classic kind of El Nino setup. Maybe not strong, but certainly El Nino-ish, which means this sort of, if you believe this chart and you believe a model going 3 months out, what it's kind of saying is at a minimum, it's going to be a normal winter. One would say perhaps enhanced in terms of swell production, maybe not in terms of rain for California, because we think, well, there's a whole nother discussion about that. We won't get into it right now. But in terms of swell production, looking, on a 1 to 10 scale, a 5, maybe a little bit better, maybe a 6, maybe a 6.5, something like that. Hard to tell. It depends how all this evolves. All right, what's going on at depth in the ocean? Okay, West Pacific here, East Pacific here. These are the anchor lines in the TAO buoy array strung across the equator from 2 degrees south to 2 degrees north. These are the X's are the sensors, and this gives you your water temperature profile. Warm water, 30-degree temperatures, holding at 170 east. In the far West Pacific, the 28-degree isotherm line holding steady as compared to last week at 160 west. The 24-degree isotherm holding steady again, 115 west. So no real change. And then light, warm temperatures moving into Ecuador. But it is the anomalies, differences from normal for this time of year. And what we see is no colder than normal water anywhere in the Pacific. Right there, that's a sure sign that La Nina does not exist in the ocean anymore. And that is a good sign. Even though atmospherically, there's still a lot of weirdness going on that suggests La Nina is going on. But the ocean's changed. It's made up its mind. We're moving towards, I don't know if I want to call it El Nino, but a warmer state. Look at this. 2 3-degree anomalies just off the coast of Ecuador, 2 more patches straddling the dateline or near the dateline, a full, just a river of warmer than normal water. This is 1, 2, 3 degrees centigrade, so a bit warmer than that, 5 or plus degrees moving into and across the Pacific under the equator. This is a Kelvin wave. This is good news. When this warm water starts erupting off of Ecuador, it'll start increasing precipitation in the far East Pacific, Equatorial Pacific. That starts feeding the jet stream, and then that's what helps set up El Nino. Another modeled view using that same data. Remember, we only have little sensors hanging on some buoy lines down here, and then the model tries to fill the gaps. But it's basically saying the same thing. Broad. This is what one could call a clear clearly defined Kelvin wave, warm water pushing from the west to the east. Here's the last little bit of the upwelling phase of the Kelvin wave cycle, cold water. This warm water is going to push right up in here and hopefully erupt on the ocean surface. We see little bits and pieces of it here already at like 105 and 120 to 140 west, but not particularly strong at the moment. We're hoping for more. Sea level anomaly data, basically the same as what we've been seeing for weeks now. Again, this is JSON2 satellite data. Strip out all the waves, strip out the wind waves, strip out the tides. You see this 5 to 10 to 15 centimeter bulge on the ocean's surface. There's New Guinea right there. What that means is there's warm water at depth. Warm water, of course, expands, and that creates that little bulge on the ocean surface. And it's filling the entire equatorial Pacific up to 120 west. That's a point south of California there. And trying to make its way into the Galapagos, that area. But the Kelvin wave needs to move east more before it fills up in here. We want to see some of this erupt to the ocean surface. And yet one more view going back in time. West Pacific here, East Pacific here. This is temperatures in the upper 300 meters of the ocean surface. Last year, October, November, cool water in the East Pacific. Classic sign of La Nina. Warm water sequestered in the far West Pacific. Little Kelvin wave. You see warm water tried to ease across the Pacific in January. It died. Upwelling phase of the Kelvin wave cycle, cooler water. Next Kelvin wave, massive westerly wind burst in February of this year, created by the active phase of the MJO, pushed warm water to the east. It kind of stalled and then finally came on shore in the June time frame, not making as much of a signature on the surface in the East Pacific as one had hoped. And then you see, you can kind of draw a line right through here. Upwelling phase of the Kelvin wave cycle, last little bit of cool water, all but gone now. And now, comparatively, look at the size of this next Kelvin wave. We're calling this Kelvin wave number 2, as compared to Kelvin wave number 1. The aerial coverage of these oranges, considerably bigger. Maybe not as much intense red, but still good solid footprint. That is moving. You can see it moving off to the east. This guy probably would show up in the November-ish time frame over the Galapagos. Takes 3 months, sometimes 4, to make it the whole way across the Pacific. So this is a slow-moving but very heavy and powerful train. All right, so what's going on in the ocean surface? And the short of it is, really no change from last week, no change from the week before. We have a lot of warm water. The reds, oranges are warmer than normal water. Greens and blues are slightly cooler than normal, so we have a little bit of cooling off of Peru. When you have a real El Nino going, temperatures get quite warm in Peru, but that's not till typically December. But notice we have these little, just continuous string of warm patches erupting. So what do we say? Warm anomalies from 120 to 140, based on the Kelvin wave analysis, subsurface temperatures. That's about right. I think we said another little patch somewhere around 100, so yeah. Maybe, but there's still just these spotty cool patches that keep showing up and just will not disappear. And that's been, it seems like there's east anomalies blowing in here, little patches that cause upwelling, cool upwelling, even though, the Kelvin wave number 1 is done. Kelvin wave number 2 is on its way, but it hasn't manifested itself at the ocean surface yet. Trend the past 7 days, well, we do see a little bit of warming directly, and it's just the equator right here that we're interested in. Everything else is kind of noise level, really. You see, and this is just the past week trend. Yeah, still these little patches of cooling out here around 100 to 120. Then little patches of warming, kind of a mixed bag pattern. Not really warming along Peru. So just kind of indicative of this mixed pattern. El Nino just can't quite get its footing yet. And then the overview pattern, cooling off of Peru down into Chile, or cooler waters, lightly cool, a degree or something. And then patches of warming intermixed with patches of cooling. El Nino, you want to see warming looking like this. We're seeing the whole bottom half of that triangle. It would be pretty much a triangle like this. All cool down in here. This doesn't look like El Nino right now. It doesn't look like La Nina at all, because when you have La Nina, then you get cooling all along here. Well, so we're seeing, like faint remnants of it, and we're seeing warming like El Nino is trying to get going, but it just can't get there yet. So what's happening? Well, the atmosphere has been in La Nina for two years. It isn't just going to change on a dime just because a Kelvin wave shows up, just because, it looks like maybe there's a low pressure bias out in here, all that. It's going to take a while. The atmosphere is trying to change. The ocean certainly is changing subsurface, but it hasn't made it to the surface yet. And it's not till the surface really changes that the atmosphere above it will sense it completely. And then they could say the atmosphere and the ocean are coupled, and they all start aligning towards the same thing, which would be a warm pool building here. And then that starts imparting energy to the jet stream, and then the storm pattern starts picking up and you're off to the races. But we got a Kelvin wave, a pretty big one, not supposed to arrive here until November. And then if it starts warming here, then the jet stream will start picking up, and that would probably take another month or two for that signal. And all that said, we're looking in January-ish, February before we really start seeing some clear sign of anything going on. So when you hear people say, yeah, El Nino's coming, well, there's El Ninos and then there's El Ninos. And the way things are going, just the rate of, you could typically, in a big El Nino, you would already see a well-pronounced warm pattern here this time of year. This is not a strong, well-defined El Nino at all. At best, I think it's going to be a weak to modest El Nino. And that's why we say it'll be an average year to slightly better than average year surf-wise. Precipitation-wise, we got to see warm water building in here south of California, wherever the peak of the warm water is. And we looked at the models, and they're all saying it's supposed to really peak more out here, which means this will probably not be a precipitation event for California. But that doesn't mean, but wherever the warm water is, that's where the peak of the storm production would be, which would mean the storms would be out here. California maybe would have lighter. You get a strong El Nino, you can get a lot of wind and things can get really ugly, not good for surf. But if the El Nino peak is more, we'll say at a westward displaced warm cycle or warm spot, then you get the swell without the weather, and that's not a bad thing for surf, just not great for rain and snow. Quick look at surface temperatures. Nino 1.2 region, that's like the area off Peru and Galapagos. It kind of dropped off the map here for a couple of weeks. Starting to come back, plus 0.75 degree, 0.784. And then in the Nino 3.4 region, the official El Nino monitoring region, it too kind of dropped off the map, even went negative, and now it's at 0.075. So that's basically just dead neutral. You got to be above half a degree for 3 consecutive 3-month periods. It's like 5 months running. We're nowhere near that. That's why we say El Nino, if it happens, great. Kind of hard to believe it's going to. I think the models are overhyping this a bit, but, I'd rather be pessimistic and then be surprised than be all excited and overhyped and then not have it deliver. All right, what's going on in the atmosphere? We have kind of a neutral temperature, equatorial ocean sea surface temperature pattern. What's happening in the atmosphere? Well, Southern Oscillation Index, difference of pressure between Darwin, Australia, and Tahiti. Negative numbers suggest, if they're prolonged and continuous, suggest the active phase of the MJO, and that's exactly what we're seeing. We're down at minus 27.21 today, but you sort of look at the trend. We've been positive over the past month. September, we went negative for a couple days. Then we went positive. Now we're back to negative. So, I don't know. Does it mean anything? Not sure. 30-day average. That'll sort of take some of the noise out of this. What's that today? Minus 5.37. What's it been for the past month? It was down to minus 7.5. That's not that negative. And it's sort of hovering there. So, basically, it's not neutral. It's, I'll say, biased towards the active phase of the MJO, but not seriously. 90-day average, strip yet more noise out of it. Well, where were we? We're at minus 3.78 a month ago. We went down to minus 4, and where are we today? Minus 3.79. So basically, we've gone nowhere. We are not in El Nino territory. We're in neutral territory, biased very weakly towards El Nino right now. But the good news is, we think, as the season changes and that Kelvin wave pushes east and all the other magical things happen that are supposed to happen, the expectation is that this will start dropping. How much? That's the million-dollar question. Another index, the ESPI index, basically same as the Southern Oscillation Index, but instead of measuring the difference in pressure between these two boxes, it measures the difference in precipitation. And of course, there is the Galapagos. This is basically the official El Nino monitoring region. If you have more precipitation in there, that typically means there's warmer than normal water here, and then that's good for feeding the jet stream. That's imparting energy to the jet stream. But this index, if the index is negative, that means things are drier than normal here. Today's index, minus 0.33. It was actually 2 days ago down to minus 0.47. It's starting to rebound. So this is where you get this thing where you get the sense that the atmosphere is still sensing La Niñas here. It's just not there yet in terms of El Nino. And we're pretty late in the season if you're going to have a significant El Nino. So again, it's working its way toward, it has been above this. I think it went up to 0.2 or 2.7 or something like that a couple weeks ago. Now it dropped off again. So it's basically toggling around zero, not in El Nino mode yet, basically saying neutral. Sea surface temperature forecast per the CFS model. Okay, we're almost in October. It's supposed to say sea surface temperatures are to be 0.7 degrees. Right now, we're nowhere close to that. We're pretty much neutral. So we think this model is overhyping it. And it says temperature is supposed to go up to plus 1.15 or so degrees the whole way through the winter. Again, we think that's an overhype as well. We look at all the other models. This is the projections for ENSO sea surface temperature Nino 3.4 sea surface temperature anomaly forecast. Here's all the dynamic models. Here's all the statistic models. They're all laid up on this chart. They're saying you just sort of eyeball this. Maybe 0.75 or so degrees, 3/4 of a degree above normal. So that would be El Nino. And you can look down here. Here's all the models. You can look at September, October, November, look at their projections. We're not going to go through all that, but you can actually say, okay, average of the dynamic models peaking at 0.8 or so in the November, December, January time frame, but then holding pretty much well into May. Okay, statistic models basically saying the same thing, maybe up to 0.9. So they're all pretty much in sync. They're saying some sort of El Nino with a, let's say, 3/4 degree above normal sea surface temperature anomaly, which certainly would help the jet stream, certainly would help storm production, maybe would help precipitation for California, depending on where those warm waters are. The CFS model says, okay, so here you can see the oranges are where the sea surface temperature anomalies are. It's saying warm temperatures the whole way along the equator just off of the Galapagos in October. Yeah, seems a little overhyped. November, December, January, February, March. Okay, so we'll just pick one here. We'll zoom in. So this is showing, we'll say the peak of the warm anomalies probably somewhere out here. California is right there. If the peak is out there, due north of there is where the focus of storm activity would be, theoretically. And then we read there's another research paper that just came out this week that basically talked about that exactly. You want to see more of this kind of a pattern rather than this, this is, I don't say we'll call it a Modoki El Nino, but it's not a classic, triangle El Nino along the Peruvian coast. Still, we'll see. Hard to say. This is a CFS model. We think it's overhyping it a little bit. We suspect most of the warming will be out here disconnected from Peru, etc. Okay, we're running a little bit long, so to get back to the point, good news. Looks like a storm, or at least a gale, developing under New Zealand. Ought to create some southern hemi swell about 8 to 10 days out. We'll see if it happens. That storm developing Monday, Tuesday, Wednesday kind of time frame. And then perhaps some activity in the North Pacific. The exact details still to be defined, but at least it appears that the models have a sense that the North Pacific might come online. That would be good. We'll take it. We need it. We're tired of surfing wind swell, for sure, or not surfing at all. Long-term outlook, yep, things looking better. At least a normal winter is the expectation, maybe slightly enhanced. We'll give it a 6.5 on a 10 scale. Chances for precipitation in California, probably even, just a normal year. Not below normal, just normal. Maybe a little bit enhanced, but we'll go with normal for now. So that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.